Hello friends, today in this video I will be talking about one important physics law, that is inverse square law. Many students have asked many doubts regarding the demonstration of the inverse square law and how to verify it in the case of many things, because inverse square law is applicable for light, for gamma rays, for electrostatic force, for gravitational force, in the case of magnetism, and even it is applied in non-physics topics like biology also it is applied. Now let us see here. What is this inverse square law? First we'll talk in terms of light. Let us say there is a source S here, and from this source light is getting emitted. When the light is getting emitted, as we know, all the light waves, they travel in spherical waves surrounding this from the source. Let us say from here to here the distance is radius actually for this spherical surface. Now this radius, let us say, is r here, and from here let us say I will increase the radius by double. This is 2r. Then again we will increase this, let us say 3r. From this source, at this point, if intensity of the light falling here is high, now original intensity, if it is high, when it comes to this distance, this intensity, depending upon the distance r here, right, it will change. Intensity here, since it is this point is away from here, again the intensity of the light falling here will change. Intensity here, again it will change. Now this can be represented by a formula. Now what is this formula? So intensity can be represented. Intensity is equal to power of the bulb divided by area on which this light is emanated. So this area is, since it is in a spherical shape, so I can write this as P divided by 4 pi r square. So intensity is related to this formula. P is the power. If the power of the bulb is, let us say whatever bulb I am using here, it has got some power. So bulb is, it's a constant value. So 4 pi is a constant value. So therefore, I can relate this. Intensity is inversely proportional to 1 by r square, where r is the distance. This can also be written as 1 by x square. We call it as x as the distance from the source. So it is at distance x, it is at distance 2x, it is at distance 3x, like that. Now from this formula, I is inversely related to x square. Now we will see, since it is square of the distance, we call it as inverse square law. So intensity is related to x to the power minus 2, inverse square. Now we'll verify this concept, and we'll also understand this in different forms. Now, the same diagram now, I'll write in a different fashion. From the source, let us say I have at this point, this is the area it is covering, correct? As the rays go like that, they spread like that. So at this distance, this can be written as. So now we have got 4. That means at this distance, if it is x, now it is 2x. So intensity here, if I take this intensity at this as equal to I, now intensity here at this point will be I divided by, here I is directly proportional to x square, here it is 2x, so here you will get 4x square. That means intensity here has fallen to 1/4 value at this point. So intensity here is, it has dropped down to 1/4 value. Now if you come here, that's at this point, if I draw the same diagram, it will be something like this. You see here 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it will be 1/3x square intensity will be. So I by x square. So 3 square means it will be 1/9 x square. So it will, intensity will fall down to 1/9 I by 9. Here it is I by 4. If it is I here, it will be I by 4 here, I by 9 here. Intensity has fallen down. Now, if you go further, you can draw a similar diagram where you will have, it is 4x. 4x means 1/4 square x square, this much. So 4 square means 1/16 of original intensity. So it will become 16, it will fall down to 1/16. So this is how the intensity changes. Now we will verify. So basic formula here is inverse square law means intensity. Intensity is changing. Intensity is changing as a function of square of the distance. Now, for this we will plot a graph and see how it looks. Now, for this let us say I got a values here like this. I'll say this is distance x. First, let me keep x value is equal to 1. It can be 1 centimeter or 1 meter like that. Next 2, I'll double the distance, 3, and for 4 readings we will take. Now, here in this column, the intensity is directly proportional to 1/x square. So, I'll calculate the 1/x square values. If I calculate 1/x square, it will be 1 here. And here it will become 1/4, because 2, if I substitute here, 2 square it will be 4. This is nothing but 0.25. And then I'll calculate 1/3 square, that is 1/9. So 1/9 will be equivalent to 0.1111. Similarly, 1 by 4 square, 1 by 16, if I calculate 1 by 16, it will be 0.06. Now, I'll also take log x values and log I values. Log x, log I. Why I took log x, log I? I'll tell you. Now, log x values, if you calculate here, log x is 0, log I is 0, and here it is 0.3010 log 2, and it is 0.60, here 0.4771, and here minus 0.95, and 0. Log 4, and here it is minus 1.22 for the value of I. So this I values, for that log I am calculating here. This is the x value and this is the log x. Now, when you plot the graph, if you take only x and I quantities, x and I quantities, if you take a graph like this, I values are here, x values are here, 1, 2, 3, 4, and let us say maximum value of I is 1 here, and then here it is 0.5, here it is 0.25, right, and 0.75 here. The first value corresponding to 1, this is 2, and this is 3, and this is 4. So when you plot 1 to 1, so 1 point here, first point will be here. Then 2 and 0.25. So this is 0.5 and this is 0.25. So corresponding to 2, right, your point will be somewhere. Then corresponding to 3, it is 0.11. So here it is 0.25. So 0.1 is somewhere here, corresponding to this. So point will come here. And 4 means 0.06, it is still down, almost equal, near to the x-axis. So when you plot the graph, so you are getting a graph like this. So as the distance is increasing, the intensity is falling down. This is one way of representing the inverse square law. Now, same thing we can discuss in terms of log plot also, because if I write I is equal to some k constant by x squared, right? If I, and this you call it as, this k value can be taken as 1 constant, so you have got basically 1 by x squared. So if I apply the log for this, so log I is equal to, here minus 2 log x, you will get x squared minus 2 log x will get. So now log x values are here, log I values are here, and this log I value I will call it as y is equal to minus 2 terms of x. So on the x-axis you take log x values, on the y-axis you take log I values, and if you plot you will get a straight line, and if you calculate the slope, this y is equal to mx. So m will be the slope you will get minus 2. So for that I have given the values here, log x and log I, and if you plot you will get a straight line with slope of minus 2, and that will verify the inverse square law. Now, this inverse square law is applied in the case of gamma rays, and in the gamma rays also we can verify the inverse square law, because gamma rays are nothing but electromagnetic waves. So if you have got a gamma source you can keep, and you put the detector. So detector here you can keep. Detector is a GM counter. In the case of light detector, you can use a intensity meter, you can use it, or you can use a photodiode to measure the intensity values. Here in this case you put a GM counter and gamma source is here, and as you change the distance of the gamma source from here to here at different places, if you put the gamma sources, you can get the different values in the GM counter as the counts. And when you plot the graph, you will get similar graph whatever I have told there. And there also you can write in terms of log, you can plot the graph, or without log also you can plot the graph and see how the inverse square law is verified in the case of gamma rays. Now, this is also applied in the case of electrostatic force. Electrostatic force, if there are two charges, Q1 and there is a charge Q2, and what is the force between them? Force between these two is given by, you have got 1 by 4 pi epsilon naught Q1 Q2 by d square. And these quantities, this is a constant quantity, Q1 Q2 are the two charges here, and then you have got a relation, force is inversely proportional to square of the distance. So it is applicable in the case of electrostatic force. It is also applicable in the case of gravitational force, because in the case of gravitational force you have got the Newton's law of gravitational formula, right? There we write, if there is one body here, another body here, it is mass m, its mass is m, and force between these two, it can be sun, it can be earth, and force between them, force can be written as g m by r square, right? And these three quantities are constant, and once again you will get back this formula. So it's applicable in the case of gravitational force. Similarly, in the case of magnetism, how to verify this? That is, a magnetic north pole is here, magnetic south pole is here. There are two bond magnets we are using here, right? So, and north and south, there is a force. From north pole to south pole, there is a magnetic flux lines are here, and this is the distance between the two things. You vary the distance, and once again you will get a formula here, constant multiplied by m1 m2 by d square, where m1 and m2 are the magnetic pole strengths of the magnets, and d is the distance. So again you will get F is inversely proportional to the square of the distance. Similarly, in the case of biology also, this is applied, because if you take, let us say there is source of light and there is one leaf. There is one leaf and there is another leaf at some other distance. This is a distance d, this is a distance 2d. So light falling on first leaf, light falling on the second leaf, intensity changes. When the intensity changes, whatever is happening here, the chemical change in order to produce the quantity of sugar here, it will vary. So accordingly, there is some type of research is done there, where the inverse square law is applied once again. Thank you very much.